Hi students, this is Mr. Yao. In this lesson, we are going to talk about 2.9b, where we will learn about system inequalities application, where we will have a method called linear programming. First, let's imagine a scenario. Your family is road tripping from Salt Lake to Los Angeles. Your hope is to get there in as little time as possible, which means you're trying to minimize your travel time. What are some things that could happen that would prevent you from minimizing travel time? You can pause here and come up with some answers. Now that you have thought about it, you might actually face some traffic, or you need to stop for gas or bathroom breaks, or there's an accident or anything. So all of these situations, these are all constraints. These are things that limit you in your goal to get to your destination in as little time as possible. So the word is constraints. Now, how many of you have flown on an airplane? And if you have, you might have noticed there are different kind of seats on the airplane. You have first class, you have coach, you have business class, and you might have like coach comfort or economy or whatever. And all of these different seats come with different prices. So how did the airplane company actually come up with these ticket prices? And how do they actually make the most amount of money? So here's another scenario for you to think about. An airline offers coach and first class tickets for the airline to be profitable. It must have a minimum of 25 first class tickets and a minimum of 40 coach tickets. The company makes a profit of $225 for each coach ticket and $200 for each first class ticket. At most, the plane has a capacity of 150 passengers. How many of each ticket should be sold in order to maximize profit? So what we're going to learn today is going to help us to deal with this kind of scenario. And that's actually a real life use. Of course, there are more situations, more factors to consider in real life. But at least this is something that gets us in the door. So linear programming. It is a systematic process of finding the maximum or minimum value for an objective function with certain constraints in the form of linear inequalities. For now, we can only deal with linear inequality because that's the only thing we have learned. In the future, you're also going to learn quadratic. You're going to learn different kind of curves, and they can help you to do these kind of questions even more precisely. So this process, linear programming, it is also known as optimization problem. It is helping in developing and solving a decision-making problem by mathematical techniques. Major usage: advising businesses to make the most efficient and effective use of the scarce resources and maximize revenue and profit. And here comes a few more definitions. Objective function, the function we're trying to maximize or minimize for, such as profit or energy. And for now, of course, these functions we're going to be working with are going to be linear because that's the only thing we have learned so far. Constraints, that also means limitations, such as time or funds or materials. And because these are real life situations, we also have non-negativity constraint, which is the x is greater than 0 or the y is greater than 0. Because, well, you can't have like -2 seats. That does not make any sense. So they have to actually be positive numbers, or it could just be 0 tickets that you sold. So there's no negative amount of cars sold, no negative amount of people. Next is not exactly something that we are going to learn in this lesson, but it is something that's going to be helpful for you to know. Cost, that means how much money is spent. Revenue, that's how much money is earned. And profit, that's how much money is actually made. So cost, for example, like the airplane company, they are going to need to spend money to buy the airplane, to pay the salary for the pilots and the flight attendants. They're also going to need to spend money to buy gas, to actually pay for the route they're flying, pay for the airport space, all that. That's the cost they're spending. Revenue, how much money they earn, that's basically from us buying the tickets. As for the actual profit, the profit is going to be the revenue minus the cost. Revenue minus the cost. Now, going back to what we are learning right now, feasible region. It's the shaded region that's determined by all the constraints. So the feasible region includes all the possible solutions. So the shaded region, the overlapping part, all that's going to be the feasible region. And because of we have the feasible regions, when two lines actually meet each other, they are actually having this intersection or vertex or corner points. When you have more lines, you of course have more of these points. We're going to use these points to find the maximum or minimum value. Now let's go ahead and have a look at an example. Example 1. Maximize this function right here. As for what this is, that's just the function. That's like the name of the function. Giving the following constraints. First step, we're going to graph each constraint to find a feasible region. So let's start with the easy ones, these two. X is greater than or equal to 0. Again, since it's x, that means we're crossing the x-axis, so the line is actually right here. For the other one, y is greater or equal to 0 is crossing the y-axis, so the line is right there. Next, let's deal with the top one, solve for y. Subtract x to the other side, then divided by 2, so y is less than or equal to negative 1/2 x plus, that's 4 divided by 2, so 2. 2 is right here, negative 1/2, negative 1/2. So there's my line. Next, solve for y. So subtract x on both sides, so negative y is less than or equal to negative x plus 1, divide everything by negative 1. Y is greater or equal to, that's a positive x. 1 over negative 1 is a minus 1. So negative 1 is right here, up 1 over 1, up 1 over 1, up 1 over 1. There's my other line. Now it's time to actually decide on the region or which part we are actually going to shade. So for this one, x is greater or equal to 0. That means we need all the positive x values, so it's going to be that direction. And this one, y is greater or equal to 0. That means we need all the positive y values, so right here. And the next one, the red, that is less than or equal to, so we're going to go lower, below than that. And for the purple one, after we finish solving, is actually greater than or equal to, so we're going to need the above section. So now again, let's draw them in a smaller region, above right here. And the purple is also going to be above, but the red is actually going to be below. So that means this little region is what we are going to actually shade. Step 2, identify the coordinates of all corner points. So these are the corner points. We have a corner point right here, and that actually is talking about the corner points of the shaded region, the feasible region. So corner point, and corner point. These are the 4 points. I have a 0, 0 right here. I have a 0, 2 right here. I have a 1, 0 right here. And I have a 2, 1 right there. Step 3, we're going to make a table, or not exactly a table, just like a list, listing the value of the objective function at each corner point, which means plug in the coordinates of each corner point. So this is our function. P of xy equals 2x plus 2y. And the xy, of course, that's basically our ordered pair. So let's take 0, 0 as an example. P, 0, 0, that's my first point. That means my x is 0, my y is 0, so I'm going to plug it in. 2 times x, so 2 times 0, and 2 times y, so 2 times 0 again. Add them together, that's going to be 0. Let's try another point, 0, 2. P, 0, 2. That means my x is 2 times, that's my x, so 2 times 0. This is my y, 2 times 2. Add them together, that's going to be a 6. Next, P of 1, 0. This time my x is 1, so 2 times 1. My y is 0, so 2 times 0. Add them together, that's a 2. And this is actually a 4. And then the last one, P of 2, 1. 2 times 2 plus 2 times 1. Add them together, that's going to be a 6. Next, the question said maximize. So step 4 is we're going to determine the desired solution based on the problem. The problem said maximize. So out of these 4 points, we're going to choose the biggest, which is 6. So our max is going to equal 6. But where did the 6 come from? to come from, so we're going to use this at this point, at 2, 1. And that is my final answer. Max equals 6 at 2, 1. That's example 1. Now let's move on to example 2. Go through the same process. We're going to start graphing all of these. Start from the simple one again. Y is less than or equal to 10. 10 is right here. Since this is y, that means the line is going to cross the y-axis. So it's going to be a flat line. And it does have an equal sign. So it's going to be a solid line right there. This is y is actually 10. Next, this we can write them into two different parts. That's basically 1 is less than or equal to x, and x is less than or equal to 8. Of course, if we want to regraph this, we're going to need to rewrite it into x is greater or equal to 1. So this is where that is. X is greater or equal to 1. And of course, we have the 8 right here. X is less than or equal to 8. Then we have the other line, which is right here. Y is greater or equal to x plus 1. 1 is here. So going up, going up, going up, keep going up. Let's get more points. These are the points we are going to have right here. Now it's time to decide on the region we are going to keep. So for the y is less than or equal to, so that's going to be below. X is greater or equal to 1, so that's to the right. And x is also less than or equal to 8, so that's to the left. As for the purple one, that's greater than or equal to, that's going to be above. So the second part, well, before that, we are still going to need to shade. So it's in between the two vertical lines and is actually below the top line. The shaded area is going to be right here. And just to be very clear, when you identify the coordinates, we do actually have 2 coordinates right here. So in total, we have 4 coordinates of these at the shaded area. Let's see, that point is going to be 1, 2. That point is going to be 1, 10. That point is going to be 8, 10. And that point is going to be 8, 9. So after we identify, we are going to plug into the function. The function is right here. I'm going to plug with every single point. So first, 1, 2. 1, 2. X is 1, y is 2. So 1 plus 2, that's just a 3. Next, let's see, 1 and 10. X is 1, y is 10. So plug together, that's 11. Next, f of 8, 9. That's 8 plus 9, which is 17. Last one, f of 8, 10. This is 8 plus 10, so 18. And all of these numbers, out of all of these numbers, you can clearly see 18 is the biggest because it's asking to maximize. So final step, we're going to decide the answer. Max equals 18 at 8, 10. So that's our final answer for example 2. Next, example 3. Let's start with the simple ones. Y is greater or equal to 0. That means I'm crossing the y-axis, so it's going to be right here. And you already know it's pointing up because it's greater than. As for the other one, we have to make sure x is on the left side. So x is greater than or equal to 0. That we have done in example 1 is going to be the section to the right. Now let's solve the other two. This one, solve for y. Y is less than or equal to, subtract the x to the other side. So negative 1/3 x. 15 divided by 3, that's a plus 5. 5 is right here. And I am going negative 1 over 3 as my slope. Down 1 over 3. Down 1 over 3. Down 1 over 3. And I need actually more to keep going. So that's kind of the general direction. Down 1 over 3. Now the other one, solve for y. So y is less than or equal to negative 4x plus 16. Negative 4x plus 16. Well, 16 is actually outside. So 11, 12, 13, 14, 15, 16 is around here. It is negative 4, so 12, that's 1. Then 8, that's another one. Then 4, that's another one. 0, that's another one. So this is where my graph is going to be. Okay, time to decide on the signs. For the blue one is less than or equal to, so that's gotta be below. For the purple one is also less than or equal to, so that's gotta be below as well. So if I look at this again, my blue is also gonna be here, and the greens are all just inside the first quadrant. So that means this is the section I am going to be shading. Now it's time to identify my coordinates. I do have 0, 0. I also have 0, 5. And this is going to be 4, 0. And this is going to be 3, 4. This time, I'm still looking for maximize. My function is right here. So g first of 0, 0. That's 3 times 0 plus 2 times 0, which is 0. Then I have g of 0, 5. That's 3 times 0 plus 2 times 5, which is 10. Then I have g of 4, 0, which is 3 times 4 plus 2 times 0, so it's 12. Lastly, I have g of 3, 4. That's 3 times 3 plus 2 times 4, which is going to be 6 plus 16, which is 22. So of course, since it's asking us to maximize, that's the biggest. So max equals 22 at 3, 4. That is example 3. Next, example 4. Same idea. Let's start graphing the last two. So we need to put the x on the left side and put the y on the left side. Then you notice is going to be the axis again, right here. Now let's go to the top one. This one solve for y. Y is greater than or equal to, move the 2x to the other side. So it's negative 2/3 x. 6 divided by 3, that's a plus 2. So plus 2, then down 2 over 3. That is going to be where my line is. Next, I have this. Solve for y. So this time, subtract 3x on both sides. I'm actually getting negative 2y is less than or equal to negative 3x plus 9. Then divide everything by negative 2. I got y is greater than or equal to, because we're dividing everything by a negative number, we're going to flip the sign. So 3 over 2x minus 9 over 2. So this is a little bit hard to graph. 9 over 2, that's like 4.5. So it's going to be around, oh, and it actually is a negative. So negative 1, negative 2, negative 3, negative 4 is around here. And it's up 3 over 2. So from negative 4.5 up 3, 1.5 over 2, which is around here. That's my point. And then I'm going up 3 again. So from this 1.5 up 3, that's going to be 1.5, and then over 2, which is right here. So this is kind of where my line is going to be for that second one. And it's actually going to cross this 0. Next. Solve for y. Y is less than or equal to, move it over, negative 1/5 x. 20 divided by 5, that is going to be a positive 4. So plus 4 is right here, and is down 1 over 5, which is actually going to be right here. Down 1 over 5. Down 1 over 5. That's my other line. Now it's time to decide on all the region. So the green ones are easy to identify. That's just pointing above, pointing to the right. The orange one, that is greater than or equal to, so that means I need the above section. For the light blue one, it's greater than or equal to, so that means I need the above section. For the purple one, it is less than or equal to, so I need the below section, and right here, this is where the shaded section would be. Now it's time to identify all my points. I have 1, that's 0, 4. I have 2 points, that's 0, 2. I have another point, that's 3, 0. And I have a last point, which is 5, 3. This is my function, I'm going to put it in there. So h of 0, 2, that's 4 times 0 plus 3 times 2, which is 6. Next, 0, 4. That is 4 times 0 plus 3 times 4, which is 12. Next, 3, 0. That's 4 times 3 plus 3 times 0. That's 12 as well. Last one, h of 5, 3. That's 4 times 5 plus 3 times 3, which is 20 plus 9, so 29. And clearly, that will be my biggest. Max equals 29 at 5, 3. So that's the maximum value I can have for this example. Lastly, if you're curious about the plain question, I have all the solution right here that you can have a look. Of course, this graph is going to be a bit hard to see because, well, we have some pretty big numbers like 225 and 200. But as you can see, it actually works out the same way. And having 125 coach tickets and 25 first class tickets is going to be the most profitable with that much money brought in. So that is everything for 2.9b. Thank you.